Okay, welcome to chapter 2. If you've made it this far, you can pat yourself on the back because you have just completed 10 sections or 9 sections of chapter 1. So, congratulations. So, chapter 2 deals with solving linear equations. So, first of all, what is an equation? An equation is an expression that has an equal sign in the middle. So where you have some kind of combination of variables and constants on one side, and then and the similarly variables and constants on the other side. Okay. Now equations can be solved, and when you get the answer, it's called the solution. Okay. So the solution of equation is the value, the very specific value of the variable that makes it true when you put it back into the equation. So how do we know if a number is a solution to equation? So we can do this, we can check easily by taking the number and substituting it in the variable in the equation for the variable. We simplify the expressions, and then if the left matches the right side, if it's true, the number is solution. If it's not true, the number is not a solution. So here's an example. We have determined if x equals 3 halves is a solution to 4x minus 2 is equal to 2x plus 1. So we're basically saying, okay, is this value of x, if I plug it into this equation, does that make it true? So let's go ahead and do that so we could test it. So everywhere I see an x, I'm putting in parentheses a 3 halves. Okay, so then let's go ahead and do that. So on the left-hand side, this simplifies to become what? So this is 4 over 1 times 3 halves. And then whatever way that you do it, this could be 12 over 2, or you could divide top and bottom by 2. You get 6 minus 2 on the left-hand side. So 2 times 3 halves, this cancels out. These two cancel each other out, and you get 3 plus 1. So 6 minus 2 is 4. Is that equal to 3 plus 1? Yes. And so it is a solution to the equation. So here is a picture of a model of an equation with one variable. So let's say you have here on the left side of this workspace, you have here an envelope that has something. We don't know how many counters it has, but there's 3 counters on this side. And then on the left-hand side, we kind of imagine this line to be the equation, okay? Another thing that I forgot to mention, you can also think of an equation as a balance scale. Okay, so you know when you have the scales, Lady Justice, if you have something that balances the other, they're equal to each other, right? So let's say if you had like, I don't know, some coins and you had like an apple here and they were equal, so that's kind of, if you add something to one side, it would tip it off balance. So the goal is that you maintain the equality. Okay, so looking at this, if this left side has to equal the right side, but this right side has how many counters? It has 2, 3, 4, 5, 6, 7, 8 counters. And on the left side, we have an envelope and we have 3 counters. We don't know. So we can represent that with x plus 3. Okay, now you can kind of guess how many counters are in the envelope. So how would we do that? Okay, so let's say we had this right in front of you. What you can do is take away 3 counters from each side, and you're left with that the envelope is equal to 5, so that means that there are 5 counters in the envelope, which makes sense, yeah? Okay, so there is a word that describes what we just did, and that is the subtraction property of equality. It's a property. So whenever you have an equation, when you subtract a certain quantity from one side, you need to do the same exact thing to the other side so that you can maintain the integrity of the equation. So let's say, for instance, again, I go back to the whole balance scale thing. So if you have here, you have 2, let's say you have 4 things, and here you also have 4 things. They're equal. So if I take away one, I need to go ahead and take away the other, the same thing on the other side, or else you're going to get something that's not even anymore, right? One is going to go down and the other one's going to go like this. So we don't want that. We want them to stay equal. So anytime that you subtract something from one side of the equation, you need to do exactly to the right side so that you maintain equality. Okay, so let's look at what that would look like. So here you have y plus 37 is equal to a negative 13. Let's say I want to get this y by itself, and I do the opposite, which is subtract 37. I can do the same thing to the other side, and I maintain the equality, okay? Because 37 minus 37 is just 0. I don't need to be writing down 0. I know it, doesn't change the value of the y. So negative 13 minus 37, remember, same signs add, and this is going to become minus negative 50, sorry. So that's that. So let's go ahead and do another example. Here you have x plus 19 is equal to negative 27. In order to get x by itself, we subtract 19 from both sides. And what does that become? Here we get x, and on the right-hand side, we get what? We get 27 plus 19, which is what? 46, negative 46, okay? So if you guessed the same thing, then good job. Okay, so similarly, if you might think to yourself, well, if subtraction works, addition should also work. So then go ahead. So here we have a minus 28, and on the right-hand side, we have negative 37. So in order to get a by itself, so we can add 28 to both sides, and that still maintains the equality. So let's go ahead and do that. So we usually just write it right underneath. And then we solve for a. On the left-hand side, those 28s cancel out. And on the right-hand side, we get negative 37 plus 28. So what is that? That's the difference, right? You subtract because one's positive, one's negative. Okay, so then that would be negative 9. Remember, it stays, it keeps the sign of the larger. So that would be negative. Okay, so for this one here, so remember, you can always pause me and try it out for yourself, and then go ahead and see if you got it correct. Okay, so here we have n minus 61 is equal to negative 75. In order to get rid of this 61, we want to solve for n. We would go ahead and do the opposite, which is add 61 to both sides. That would cancel this out. And then you would get negative 75 plus 61, right? We would subtract and keep the sign of the larger, so that would be negative 14. Okay. All right, so let's do some more super fun examples. So go ahead and pause this, try it on your own, and then we'll come back and and go over them. Okay, so here we go. We have p minus 2/3 is equal to 5/6. So if you thought to yourself, okay, I'm going to add 2/3 to both sides, that's correct. So on the left-hand side, you have the letter p, the variable, and on the right-hand side, you have 5/6 plus 2/3, but 2/3 is equivalent to what? Because we can't combine the two fractions without having different denominators. So we need to change the denominator, okay? So 2/3 is equivalent to 4/6. So 5/6 plus 4/6 is 9/6 today, and that is that, okay? You can reduce this also, sorry. So if you divide top and bottom by 3, that would become 3/2. So that's actually more correct, 3/2. Okay, so now here we have n minus 0.63 is equal to negative 4.2. So we're going to add up, 63 hundredths to both sides. Okay, so then you would get n is equal to, and then we have negative 4.2 plus 0.63. So we're going to combine, we're going to subtract, right? Because they're different signs. And then we keep the sign of the larger. Okay, so that's going to be negative 3.57. Okay. All right, so let's continue here. We're just going to add 47 hundredths to both sides. And this cancels. We bring down the b. And on the right-hand side, again, it's going to be subtracting. So 2.1, 0 minus 0.47. But remember, we're going to subtract, but we keep the sign of the larger. So it would be negative 1.63. All right, so let's continue here. We would do the same thing. So see the pattern? These are called one-step equations because it just takes one step to solve them, okay? So here we have negative 4.6 plus 93, so that's the same as subtracting, okay? And then you would get a negative answer, negative 3.67, okay? All right. Okay, so before we isolate the variable, we should always try to simplify as much as we can. Okay, so if we want to simplify, we would also do like terms and then divide or multiply whenever we can, okay? So what is to simplify an expression? It means to do all the operations in the expression. So basically combine like terms, okay? So simplification. So when you say simplify, that would be the first step. You would basically do combine all like terms on each side of the equation, okay? Of equation. Okay, so let's say here you have 9x minus 8x, and then you have minus 5 and minus 6. So on the left-hand side, 9 minus 8 is just 1x, so that takes care of these two. And then you have a negative 5 minus 6, that's going to be negative 11, equal to 7. And now I have it where I can just add 11 to both sides. Okay, and I get x is equal to 18. All right, let's do another one. Here we have 8y minus 7y. Okay, and then here we have negative 4 minus 7. So combining like terms, 8 minus 7 is just 1y today. And then we have, that takes care of these two. And we have negative 4 minus 7, that's minus 11, and that's equal to 4. So to solve for y, we would add 11 to both sides. Oh, that's funny, they're both 11. And then you would get y is equal to 15. Okay. Let's do some super fun more examples. So first thing that we're going to do here is what? So on the left side, we're going to simplify the expression on the left-hand side of the equation. And to simplify it, we first need to do distribution property. We need to use the distribution property, yeah? So this is going to be 5n minus 20 minus 4n is equal to negative 8. So let's go ahead and identify the like terms. We have 5n minus 4n, that's just n, 1n. And we bring down this minus 20 equal to negative 8. And then we just add 20 to both sides. So this is like a two-stepper, right? So we get here n is equal to negative 12. Right? Different sign, subtract. Okay, so here we're distributing the 5. So we get 5p minus 15. Bring down everything else. I'm not even really thinking. I'm just writing stuff down. Okay, now let's go ahead and identify the like terms. We have 5p and 4p, so that's just 5 minus 4 is 1 today. And we don't need to write that down in the coefficient because we know that when you just see the letter by itself, we know that there's like an invisible 1 in front of it, yeah? So then we bring down this minus 15 and the equal sign, and we bring down this negative 10. So then again, to solve for p, we do the opposite, which is to add. Okay, so then that cancels it on the left-hand side, and on the right-hand side, negative 10 plus 15 is subtraction. That would be 5, and we keep the sign of the larger number, which is positive. Okay, okie doke. So let's go ahead and do this last example. So we're going to distribute the 3. That's going to be 6y minus 3 minus 5y is equal to, and let's go ahead and distribute this and this. So we have 2y plus 2, and then the negative 2 distributes to negative 2y minus 6. And we have here, okay, fine. So now we have something. So on the left-hand side, we'll do like terms. 6y minus 5y is just 1y, or just y. And then we have this negative 3 to bring down here, minus 3. Then the equal sign, and now we do like terms. 2y minus 2y, that cancels itself out, right? Because anything subtracted by itself is 0. And you have positive 2 and a negative 6. So when we combine positive 2 minus 6, we subtract, different sign subtract, and you keep the sign of the larger, so this is going to be a negative 4. Are we done here though? No, we're not, right? So we have y minus 3 is equal to negative 4. How do we get rid of this 3 here? Because our goal is to get the variable by itself. And you'll see in the textbook and everywhere else, they say isolate the variable, isolate the variable, isolate the variable. What does that mean? That just means, hey, get the variable by itself. Okay, so I'm going to add 3 to both sides. And then we get y is equal to negative 1. That's right. Okay, so now let's talk about how to translate English to algebraic equations. And you're going to keep seeing this, okay? So get familiar with it. Don't be scared just because it says, oh no, word problems. I know a lot of you guys, not everybody, but a lot of people will think, oh, word problems, and then their brain just kind of shuts down a little bit. Don't let it do that, okay? You have to say, no, gotta try to have a growth mindset, okay? Say to yourself, okay, I don't understand this, but I'm going to. I don't understand this yet, but I will, okay? So the quicker you start having that positive self-talk to yourself, the more, trust me, things will start to become more clear to you, okay? Okay, so let's go ahead. So some key words that tell us to write an equal sign are is equal to, the same as, result is, gives, was, and will be. So let's translate and solve. 11 more than x is equal to 54. So what does 11 more than x look like? So you have x, and then you have 11 more than. Remember that means to add. And then this equals to, that's just the equals, and then 54. Okay, so now if we want to solve it, we need to subtract 15 from both sides. We get x is equal to, and then 54 minus 15 is going to be 39. Positive. All right, let's do some more. Again, you can always pause the video, work the problems, and then check your answers. I highly recommend that, okay? Because that's what I would have you do in person. So if you could do that, that would be great. Okay, so let's translate this out. 12 less than x is equal to 51. So what does that mean, 12 less than? Remember, that means that the x comes first, and then you say, oh, this is 12 less than that, so you're subtracting 12. Okay, and then of course the words is equal to, that just means, okay, you write down the equal sign, and then what's left, the number 51. Okay, so solving for x, we're going to add 12 to both sides. We're going to use the addition property, right, of equality. So that cancels it out on the left-hand side, and on the right-hand side, we're just adding. So that's going to be 63. Okay, let's do another one. The difference of 4x and 3x is 14. So when you say the difference of something, remember it's going to be first and then second. So 4x minus 3x, that's the difference of 4x and 3x. The word is here tells you, hey, write down the equal sign. And then the number 14, you just bring that down, okay? So 4x minus 3x just becomes x, bringing everything else down. That's your answer. X is equal to 14. Okay, so in general, when you have an application, the first thing that you do is read the problem, make sure you understand all the words and the ideas that the problem is giving you. The second thing is, the next step is to identify what is this problem asking me? These are questions you need to be saying to yourself. What is this problem asking me? What's my goal here? What am I looking for? Okay, so once you have a name to that, that's your variable. Okay, so once you figure out what the problem is asking you for, that's your X, your N, your S, your T, whatever you want to call it, it doesn't matter. Smiley face, variables could be anything. They're kind of dumb. They're just placeholders. Okay, then you have your variable represents whatever it is that you're looking for. Then you translate the words into an equation using that variable, okay? And then you solve the equation with algebra and you check the answers. So let's go ahead and do a problem. Okay, so you have here the McIntyre family recycled newspapers for 2 months, okay? That seems important. I'm gonna underline that. The 2 months of newspapers weighed a total of 57 pounds, okay? The second month, the newspaper weighed 28 pounds. How much did the newspaper weigh the first month? Okay, so we've read the problem. We see what they're trying to tell us. And I know a lot of you, there's a percentage of you that's going to go, I don't need to write down the equation. I can do this in my head. I already know that. But that's not what we're exercising here. We're exercising reading a word problem and translating it into symbols. That's what we're doing. Okay. So even if you can do this on your own, kudos to you, but make sure that you understand how to translate this into an equation. Okay. Okay. So what are we looking for? The question says, how much did the newspapers weigh the first month? So that's going to be our variable. So we're going to say X, my variable is the first month's weight of newspaper, right? So first month's weight, right? Newspaper weight. Okay, so that's what X is. Okay, now there's two of them. So you have the first month, and then it says here a total. So what does a total mean? That means that you're going to add something together and it's going to be a total of 57, right? Because there's only two of them, it's fair to assume that you're going to have X plus something. Now it says here the second month, the newspaper weighed 28 pounds, right? So second month's weight was 28 pounds. So we're going to add first, which is X, and we're going to add that to the second month, which is 28, and that's going to equal the total of 57 pounds, okay? So boom, all these words simplified, translated to one algebraic sentence. It's very beautiful. X plus 28 equals 57. It's very nice, okay? So now that we have that, we can go ahead and use subtraction property of equality, right? We're going to go ahead and subtract 28 from both sides. And what does that equal? 57 minus 28, 29. So X is equal to 29. Not too bad, right? And so, of course, there's always going to be someone that says, well, I could have done this in my head already. Of course you can, and that's okay, and I encourage it. But make sure that you're learning the skill here. What's the skill that we're learning? How to translate English into symbols. So, make sure that you're understanding that. Okay, so here we go. The Pappas family has two cats, Zeus and Athena. Together, so this is another keyword, together they weigh 23 pounds. Zeus weighs 16 pounds. How much does Athena weigh? So again, if you think you got it, feel free to push pause and write your interpretation down, and then let's see if we match, okay? All right, so we have two cats. We have Zeus and we have Athena. So their weight, I'm talking about their weight. Okay, what are they asking for? They're asking for Athena's weight. So Athena's weight is going to be our X. Okay, so we're going to let X equal Athena's weight. And Zeus's weight is 16. But together they weigh 23. What does together imply? That means that you're going to do what to these two weights? We're going to add, right? So together Zeus plus Athena is 23 pounds. That's together. Okay, so Zeus is 16 and Athena is X. But I'm going to go ahead and put the X first because that's the way that we actually did it. So let me go ahead and do that. Sorry. So X plus 16. And then from here, you just subtract, right? Okay, so X, which is Athena's weight, is equal to what? 7. Obviously, she does not weigh very much. Okay, let's do another one. Sam and Henry are roommates. Together, they have 68 books. So Sam and Henry, okay? Sam has 26 books. How many books does Henry have? And that's funny that I said X because that's exactly our variable, right? So again, going through the steps here, we've read the problem. What is this problem asking you for? It's asking you, hey, reader, how many books does Henry have? So you have Henry. You say, okay, fine. Henry's book, the quantity of Henry's books is going to be X, okay? Sam has 26. Together, that's going to be a plus equals, right? So Sam plus Henry. So Henry plus Sam, right? H plus S is going to equal together, right? So that's going to be 68. The total is 68 books. Okay, so then from here, we can very easily solve by subtracting both sides by 26. So we have X is equal to 42. books. Okay. All right. Great. Oh, we already did this one. That's nice. I'm going to go ahead and get rid of it. All right, let's do this one here. Eddie paid $19,875 for his new car. This was $1,025 less than the sticker price. What was the sticker price of the car? So what are they asking for? Okay, they're asking for sticker price. So sticker price of the car is going to be X. Okay, that's going to be my X because I want to solve for that because that's what the question is asking me for. Okay, so the actual payment that he paid was $19,875. Now that's going to be $1,025 less than the sticker price. So what does that mean? When you say something is $1,025 less than something else, it's a subtraction problem, right? So this means, remember the less than goes, it switches order. This sticker price we represent by X, and there's a number. So this sentence gives us the expression X minus 1,025, and that's going to be how much he paid, which is 19,875. So the sticker price we have to add, right? We're going to have to add 1,025 to 19,875. And what do you get? Did you get 20,900? So the sticker price was $20,900. Okay, so that's it for section 2.1. Your exercises are 1 through 71 odd, maybe every other odd if you're in a pinch, but I'd really suggest that you do the odds. They're not that many. Okay, good luck, and I will see you on the next video.